Welcome to the lecture, my dear students. In the previous lecture, I have explained you about the partial derivatives of two variables, and I am going to continue with some more problems on partial derivatives of two variables. So let us now take this problem as f of x comma y is given by e raised to xy times of ln y is given, suppose. Now fx we need, suppose, that is dou f by dou x, and that is given by e raised to, now whenever I say e raised to xy times of ln y, what is the constant here? The constant is here the y term. Y is itself is ln y. So the constant is ln y. So let us drop down the constant term as it is, and then differentiate the remaining term, that is dou by dou x of e raised to xy. Now this is chain rule. What we are using here is the chain rule. Now again you need to use the chain rule here, that is ln y times of dou by dou x of e raised to xy is e raised to xy times of what is the partial derivative of xy. This is what the chain rule we are using. So it is ln y times of e raised to xy. Now what is the constant here? That is y. Derivative of x is 1. I hope you could understand. So therefore, what is the function fx is what now? It is y ln y times of e raised to xy. This is what the partial derivative of the function f with respect to x. Now we need fy, let us say. That is given by dou f by dou y. Now look at this problem. In this, you have got both the terms here. So there is a product with e power xy and ln y. Both the terms are having y and y. So here which rule we have to use? We have to use the product rule. Let us write down the product rule here. What is the product rule formula? U v dash is given by u times of v dash plus u dash times of v. This is what the product rule, right? So what we do now is, let us write down clearly. Your function here is e raised to xy times of what is the partial derivative, that is dou by dou y of ln y plus ln y times of dou by dou y of e raised to xy. So now let us do the differentiation for this. E raised to xy times of ln y derivative is 1 over y, and ln y times of dou by dou y of e raised to xy, which is e raised to xy. Now again the chain rule. With respect to y, what is the derivative of xy? It is x. So we are applying the product rule as well as the chain rule. So e raised to xy over y plus x times of ln y times of e raised to xy. This is your fy. I hope you could understand. This is the very important and interesting problem where you are applying the chain rule, the product rule, and where you need not apply the chain rule also we have done. Here when you do the fx here, no need to use the product rule. Why? Because there is ln y is the constant, because you are differentiating with respect to x. You can drop down ln y directly and do the differentiation partially for the next term. Whereas when you do the partial derivative of f with respect to y, both the terms e power xy and ln y are having the variable y. So you must use the product rule. The product rule is given by this, and hence you can solve the derivative like this by using the product rule. Again in the product rule you are using the chain rule, and then the formula for fy and fx is given by this. I hope you could understand this. A very interesting problem, of course, a critical problem also. This is when you have to use all the rules in a single problem. Please try to understand, practice properly. Thank you.